On the SAT, you're going to see several different types of charts and graphs. So I thought I would do a very, very quick run through of the various types that come up, and then we'll do a couple problems together. Let's start with bar charts. I think bar charts are pretty self-explanatory. They show frequency. So for instance, if I'm talking about the number or the number of students in a particular workout class in a particular month. Maybe in May it's this many, in June it goes up, and then in July there are more, and then it goes down, et cetera, et cetera, et cetera, right? But each bar represents the frequency for the particular month or whatever it is that we're talking about. Scatter plots. Scatter plots come into play when we are illustrating observations in the real world. So for instance, let's say that I'm collecting data on bugs, and the x-axis here is the distance away from a particular tree, and each dot represents the number of bugs at that distance. So maybe I went like 5 feet away, and there are this many bugs, and I'm filling this in, right? I'm drawing the number of bugs at a distance. And what you tend to notice with scatter plots is sometimes there's a trend, right? So clearly here, the further away from the tree I get, the fewer bugs I get. And you can do something called the line of best fit. We'll talk about that in one of our examples. But basically, the line of best fit is a line that almost forces reality into a model, if you will. Reality is a little bit messy, but this is a line that kind of describes the general trend. We'll talk about more about that in an example. Tables, you can do all sorts of things with tables. Usually there are 2 or more columns, right? Draw that, and you can have all sorts of information laid out in a table. Box and whisker plots are pretty darn rare and a little more difficult, but I'll do a very, very quick review of them. What a box and whisker plot does is it basically tells you the maximum and minimum observation in a set of data. So like, let's say that I'm talking about height. The shortest person would be right here. The tallest person would be right there. And then what it also does is it gives you a box that describes the median, right? So what this box says is that, or what this chart says basically, is that 25% of people live in this zone right here. 25% of people are between this height and this height. 50% of people are between this height and this height. And then another 25% of people are between there and there. And then, of course, you have the median somewhere in here, right? The middle value. Okay. Finally, pie charts. Break things down by the slice. So it's important to remember our rules about circles and angles in there, but you can break down data in a pie chart. So this is a very, very quick overview of the various types of charts that come up. Let's try a couple examples together. All right, pause the video and give this question a shot. So we have a scatter plot here, and I'm going to say this about graph and chart questions in general. It's so important to read all of the information that it gives you. For example, here we're talking about the price of soybeans in cents per pound. And here we're talking about the quantity produced in thousands of pounds. So it's really important to read these and to note the scale, right? So for instance, this is 5 cents a pound, 10 cents a pound, 15 cents a pound. And then as we discussed with scatter plots, each point is a point of data. So for instance, we had one piece of data that said at 10 cents a pound, roughly 190, 175 are produced. Let's look at the question. The scatter plot shows data collected on the price and output of soybeans in an agricultural community. According to the line of best fit, that's this thing, what is the expected soybean output at a price point of 15 cents? Okay, now one word about the line of best fit. The way that you draw a line of best fit, and you don't actually need to know this, but it's good to review. The line of best fit is a line that divides the points in half. So half of the points are going to be above the line and half of the points are going to be below the line. That's the technical definition of a line of best fit. And as I said a minute ago, the line of best fit is basically to make reality conform to a model. Reality is messy. There are all sorts of variables that affect things. But if you have a bunch of points like this, or even more, you can notice a trend. And that's what the line of best fit does. So what this is asking is, according to the line of best fit, according to this model, not reality, what would you expect the output at 15 cents to be? Well, there's 15 cents. If I go up to the line of best fit, I'm right around 300,000. Now, some people might have said, but in reality, the only data point we have is that when it's 15 cents, it's 200,000 pounds of output. Doesn't matter. We're talking about the line of best fit. So the correct answer here is C. Let's try another one, this time a bar graph. The bar graph shows the number of events worked by a catering company from April to June. Approximately, what is the average month-to-month increase of all consecutive 2-month periods shown in the graph? All right, so when I say consecutive 2-month period, I mean April to May is a consecutive 2-month period, May to June is another one, and June to July is a third. So there are 3 consecutive 2-month increases. So if we're talking about percentage increase, the increase from April to May is from 10 to 20. You can use your percent change formula, the either good old-fashioned one or the shortcut that we had, and find that that is a 100% increase. New minus old over old. So 20 minus 10 over 10, right? New minus old over old. And that gives us 100% or 1. Then I go from 20 up to 35. Well, if I do my calculation there, that is a 75% increase. And then if I go from June to July, that's 35 to 40 approximately, right? That is, I think it was 14%-ish. Double check that on your calculator, but 14%. And when I average these 3 numbers together, I don't even need to really do the math, but I can look at this and know that it is 63%. Now, one question that you might have, and this is an important one for charts and graphs, is like, how much am I allowed to approximate? I'll put it this way. Do you notice how far apart these numbers are? Like, even if you had wildly overshot or undershot this one, it looks to be about 35. But if you had said 32 or 30, 38, like you'd still be all right, right? The numbers are clear enough, and the test makes it so. So the correct answer here is A.